Hello friends, we are back with our new video. In this video, I will discuss how to create a student's qqplot in R or R Studio using ggplot2 that you can use for your official presentation or in your publication. Please visit our website statswithR.com for more details, and if you have any queries, shoot us an email at learnstatisticswithr@gmail.com. The overall process involves some steps, and I will discuss every step so that you can change some of them according to your requirements. So let's begin. First, I just give you a brief overview of what a student's qqplot is. We have discussed the normal qqplot in our previous video. Some of the facts about the student's qqplot are similar to those of the normal qqplot. Suppose you have some observations x1 through xn, and you want to check whether a student's t-distribution fits your data well or not. Here we assume the student's t-distribution has three parameters, one each for location, scale, and degrees of freedom. Note that this is different from the default student's t-distribution in R, which has only one parameter for the degrees of freedom. The first step of a student's qqplot is fitting a student's t-distribution to your data and estimating its three parameters. Next, you calculate low through high data quantiles and also the corresponding quantiles of the fitted normal distribution. Then you plot the quantiles of the student t-distribution along the x-axis and call it theoretical quantiles, and also plot the corresponding data quantiles along the y-axis and call it sample quantiles. Here you try to see whether the two types of quantiles are close to each other or not. If they are close, you might say that a student's t-distribution fits your data well. A very important thing is to note that the terms mu hat, sigma hat, and nu hat are random quantities, and so each theoretical quantile is a random quantity here. For illustration, I have simulated 10,000 observations from the student's t-distribution with mu equals to 175, sigma equals to 10, and nu equals to 10. First, here we create a normal qqplot for the simulated data following the steps discussed in our video how to create a normal qqplot in R using ggplot2. Note that the sample quantiles are larger than the theoretical quantiles on the right tail and the opposite is on the left tail. This indicates that the sampling distribution have heavier tails than that of a normal distribution, and you need to fit a model that allows heavier tails than a normal distribution. The obvious first choice here is the student's t-distribution. So today I will discuss how to create a student's qqplot using ggplot2. So let's start. Here I assume that you know how to load your data into R or R Studio. Suppose you have a numeric vector of observations and you store it in a variable, say x. First, you have to estimate the three parameters of the student t-distribution. For that, you need two packages, fitdistrplus and metRology. If you haven't installed these packages yet, install them from CRAN using the command install.packages. Once you have installed, call them using the command library. Now you are ready to obtain the maximum likelihood estimates. In the console window, type fitdist within brackets x distribution equals to scaled.t within quotes, and then you need to set the starting points for the optimization. Note that the distribution normal mu comma sigma square coincides with the student's t distribution if nu equals to infinity. So some good starting points would be mean of x for mu, standard deviation of x for sigma, and some reasonable high value of nu, say 30. You need to set these initial values as a list. Now press enter. Okay, you get the maximum likelihood estimates. The standard errors are the extra information here. We don't need them. You store the output in a list par.est. To get only the MLEs, use par.est $estimate. Now let's move on to the qqplot. If you haven't installed the package ggplot2 and qqplotr, install them from cran using the command install.packages. Once you have installed, call it using the command library. Next, in the console window, type ggplot mapping equals to AES sample equals to x plus stat qqpoint within brackets distribution equals to t dot scaled within quotes d params equals to the fitted MLEs and size equals to 2. The default size in the function stat qqpoint is 1.5. So if you are happy with that, you don't need to mention the argument size. Now press enter. Okay, you get your first student's qqplot using ggplot2. The first thing is the axis labels are not clearly written and you might want to write them properly. So add xlab theoretical quantiles within quotes plus ylab sample quantiles within quotes. Now press enter. Okay, you get your second student's qqplot. In general, we always add a reference line to the qqplot, that is the straight line y equals to x. This helps us to understand how much the data quantiles deviate from the theoretical quantiles. To do that, add stat qq line, then within brackets set the distribution equals to t dot scaled within quotes and d params equals to the fitted MLEs. Now press enter. Okay, you get your third student's qqplot using ggplot2. We see that some quantiles, particularly at the tails, deviate from the line y equals to x. You might feel that a student's t distribution is not a good model for this data. So let's get deeper. Note that the theoretical quantiles are functions of the estimated parameters. Thus, the theoretical quantiles are random quantities. If you change the data, they will also change. So it is always a good idea to draw pointwise 95% confidence intervals along with the line y equals to x. To do that, add stat qq band within brackets, set the distribution equals to t dot scaled within quotes and d params equals to the fitted MLEs. Note that here the ordering matters and you should specify the command stat qq band before stat qq point and stat qq line. Now press enter. Okay, you get your fourth student's qqplot using ggplot2. You see that despite some points being far from the reference line, they are within the confidence band. So far, we are mainly done with the qqplot for your personal use. Now let's add some more things to make it a publication or a presentation quality one. These steps are similar to other ggplots that we have already discussed in our channel. Now, suppose you want to add some description of the data in the title. Say you are working with a dataset of heights and you want to add students qqplot of heights. To do that, add the line ggtitle within brackets students qqplot of heights within quotes. Now press enter. Okay, you get your fifth students qqplot. You can see that the title is printed now. Now you might want to move the title to the center. To do that, add the line theme plot.title equals to element underscore text h just equals to 0.5. Okay, now press enter. Okay, you get your sixth student's qqplot. You can see the title is at the center now. Now you may feel that the fonts of the title, the axis labels all are very small and you want to enlarge them. To do that, add the line theme axis.text equals to element text size equals to 20. This increases the font of the axis. Axis.title equals to element text size equals to 20. This increases the font of the axis titles. And plot.title equals to element text size equals to 20. This increases the font of the plot title. If you don't want one or two of them, you can remove that line. The larger the size you want, you need to fix a larger number. So choose a number accordingly. Okay, so finally you get a student's qqplot using ggplot2 that you can probably consider to use in your presentation or in your publication. If you see that your dataset shows evidence of a non-identical distribution assumption, you might need to fit a regression model, and to judge the fitting, you need diagnostic plots. To do that using ggplot2, watch our video How to Visualize a Linear Regression in R using ggplot2. If you found this video helpful, please like, comment, share and subscribe to my channel and press on the bell icon for more updates.